Okay, in this video I want to do another example of a solid of revolution problem. And I want to find the volume that results when the region bounded by these functions is rotated about the x-axis. So as usual, I want to start by visualizing what's going on here, right? So the first thing is that I have y equals 1 over the square root of x. So that's going to look something like this. Okay. And my region is bounded by x is equal to 1 and x is equal to e. So let's say that x is equal to 1 is right here, and then x is equal to e, maybe that's right here. And I'm rotating this region about the x-axis. So I'm rotating it this way. Okay? So we want to figure out which method we want to use, right? Because we always have two methods available to us. We have shells and we have washers. And we want to use whatever integration method is more convenient for us. So like in this case, I'm starting with this function. I have y equals 1 over square root of x, right? And this is a function of x, right? So that indicates that whatever method I use, I want to be integrating in terms of x. So I want to be integrating like this, right? Because when you integrate with respect to x, you're taking a bunch of little rectangles that are going vertically like this. And then the width of each of these rectangles is the dx. Okay, so in this case, what does that mean? Well, if I have all of these rectangles and they are sitting vertically like this, and then I'm rotating them around, what does that look like? Well, that looks like a washer, right? So when you take a vertical slice like this, and you rotate it around, that gives you a washer shape, kind of like this, right? So that means that I want to use washers. What is the formula for the volume using washers? So washers, it's the integral over a to b, and then you want pi times whatever your outer radius is squared. Okay, and then minus whatever your inner radius is squared. And then you integrate, in this case, dx. So in this case, I know that my a and b, I know what those are. So I know that my a is going to be equal to 1 and my b is going to be equal to e. Okay, and then I also know that my outer radius is 1 over square root of x. So I'll put 1 over square root of x squared. And then technically my inner radius is 0. So I'll just put minus 0 squared. Like this. So as usual, I want to pull out this pi, right? Because that's just a constant. And then what do I have? I have the integral over 1 to e. 0 squared is just 0. And then I have 1 over square root of x squared. So that's the same as 1 over x dx. But remember, so the integral of 1 over x is equal to natural log of x. So my integral is the same as pi times natural log of x, and then we want to evaluate at 1 and at e. So I have natural log of e minus natural log of 1. Okay, but the natural log of e is just equal to 1 because the natural log and the e cancel each other out, right? So this one's just equal to 1. And then the natural log of 1 is equal to 0. So that means that what I have here is the same as just pi times 1. So that means that my final answer is just equal to pi. And that's it. Thank you very much for watching.